Assalamualaikum warahmatullahi wabarakatuh. We are from group 2. We would like to explain elasticity and plasticity in mechanical engineering. Plasticity, on the other hand, refers to the permanent change in the shape of a material when subject to external force. To close this video, let's understand these interesting material properties together.
When we hear the word elasticity, the first picture that comes to our mind is something like this. But is this really what elastic means? We will find that out in this video. Let's take an example of a helical spring. When a force of compression or tension is applied, the helical spring gets deformed, that is, it changes in shape or size. This force is referred to as the deforming force. And the ability of an object to regain its original shape when the influence of this deforming force is removed is called elasticity. More examples of such objects include sponge balls and rubber bands. When compressed or stretched, they get deformed, but they soon return to their original shapes. This self-reversing deformity the object goes through when forces applied and removed is called elastic deformation. But is there a limit to the elasticity of an object? Do elastic objects remain elastic forever? Not really. For instance, if a great amount of force is applied to a spring, it simply won't be able to stretch further than a certain point. But if the force becomes excessive, the spring will get permanently deformed and may even break if we keep increasing the force. Hence, the spring does not remain elastic forever. This type of deformation, where the object is unable to attain, or if it only partially attains its original shape once the deforming force is removed, is called plastic deformation. Now let me ask you a question. Suppose we have a rubber string and a string made of steel, both of very tiny thicknesses. Both are identical to each other in terms of size and shape. If we stretch them from both the ends with equal and opposite forces, then which one will stretch the farthest, assuming the deformation is elastic in both the cases? Quite obviously, the rubber string will stretch the farthest. The steel string would barely stretch, but it is important to note that it would indeed stretch no matter how little. It doesn't stretch as far as the rubber string because steel applies more resistance to the deforming force than the rubber does. Moreover, as soon as the force is removed, the steel string regains its original shape and size quicker than the rubber string. It won't allow a deforming force to change its dimension as easily. So, which one would you say is more elastic? Steel or rubber? You would think that the obvious choice has to be rubber, but unfortunately, that's incorrect. There is a general misconception that a lot of us have about elasticity. We think that the more the object gets stretched or compressed, the more elastic it is. But elasticity is not the same as flexibility. In the language of physics, the term elastic has a very different meaning. In physics, we say a body is more elastic if it resists more to the deforming force and reverses back quicker to its original shape after the force is removed. And since steel resists more and reverses back to its original shape quicker, it's more elastic than rubber. We can mathematically define elasticity as the ratio of stress to strain. We'll teach you what stress and strain mean in the upcoming videos.
Up until this point, we have lived and watched a video about the fascinating properties of elasticity and plasticity in the field of material science. Thank you for attention and participation in this video. The lesson we can take from elasticity and plasticity are two important mechanical properties in mechanical engineering, applicable to both rubber and steel is a future explanation. Elasticity, rubber. Rubber has high elasticity. This means that when rubber is subject to stress of deformation, it will return to its original shape once the load is released. Examples of elasticity application in rubber of mechanical engineering are rubber springs. Rubber springs are used in various applications such as in vehicles for suspension system or vibration dampers. Elastic pads. Elastic pads are used to reduce impact or vibration in machinery or equipment. Next,
Steel. Steel also exhibits significant elasticity. This means that when steel is subjected to stress or deformation, it will return to its original shape once the load is released. Example of elasticity application in steel for mechanical engineering are steel springs. Steel springs are used in various applications, such as in vehicle suspension or door mechanism. Steel structure. Steel is used in structural construction, such as buildings or bridges, where elasticity is important for withstanding changing loads and force.
Plasticity. Rubber. Plasticity in rubber is limited. However, in some cases, plastic deformation can occur in rubber at a microscopic scale. An example of plastic deformation in rubber for mechanical engineering is rubber seals. When a rubber seal is placed between two closed surfaces, it undergoes plastic deformation to accommodate irregularities and ensure minimal leakage.
Two, still exhibits more significant plasticity. This means that when steel is subject to stress or deformation beyond its elastic limit, it undergoes permanent plastic deformation. Example of plastic deformation in steel for mechanical engineering are metal forming process like plate forming, casting, or bending. Utilize plastic deformation to shape metal component according to the desired from steel extrusion. The extrusion process involves applying high pressure to transform steel into desired profile such as pipe or other metal profiles.
And in conclusion, understanding elasticity and plasticity in rubber and steel plays a crucial role in designing and selecting material in mechanical engineering. It enables engineering to choose appropriate material for specific application, considering the elasticity that restores shape and the plasticity that allows permanent deformation. We hope that the information we provide has give valuable insight into elasticity and plasticity. We apologize for any shortcomings. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.